everyone. Today we're going to continue our investigations on physical sciences. Before we get started, I have a beaker here. Now we're going to take a closer look and I want you to guess what's inside. By the looks of it, looks like water, right? Let's take a closer look and find out. Here is a closer view from up top. As we look, we see clear, colorless liquid behaving like water. And here is a side view. Again, looks just like water. One other way to find out if it's just water is by touching it. I'm going to put my hands inside and well, look at that. What's inside? There was water inside, but there's something else. These are jelly marbles. Well, how cool was that? I didn't think there was anything else inside of there but water. But when I put my hands in, these little jelly marbles, or Orbeez, as we like to call them, clear and colorless, just like the water, but we couldn't see them. To be able to understand this a little further, today we're going to learn all about light. Few things that we need to learn about light before we can understand it a little bit better. Light travels in a straight line. I have my laser pointer, and we'll see that as I point it, we see that it's traveling in a straight line. I'm pointing it exactly where you see that red dot. My laser pointer demonstrates that light travels through a straight line. Let's do another experiment and see what happens when I take a regular pencil, another beaker filled with just water, and I'm going to drop my pencil in. Let's see what we notice. Well, now what do you notice? Looks like my pencil is broken in half. There's a part that's coming as soon as it touches the water. It looks like the rest of it is over here. What is going on? Let's take it out, make sure my pencil is not broken. And let's drop it in again on the other side, and well, the same exact observation. The pencil looks like it's broken. To understand what's happening here, we need to investigate light a little further. Remember, I had my laser pointer, and I told you that light travels in a straight line. But light can behave in a few different ways. Let's talk about a mirror for a second. What happens when you look inside of a mirror? Well, you see a reflection of yourself. Light reflects, and that only happens, you can only see that reflection when you have light. Objects need light to be seen, and for there to be a reflection, there needs to be light. Here I have a mirror, and as I look into the mirror, I can see my reflection. Light is able to reflect my image back. This mirror reflects the light back. It's not just mirrors. Other objects that you might notice, such as metal, are also reflective. It's going to be important because we're going to revisit that in future lessons. What do you see? A reflection. There's something else that light does, and that's refraction. Refraction is the bending of light. A light, I told you, travels in a straight line. It's traveling at a certain speed through air. But as it hits water, at a different speed. It actually slows down and it bends. It travels and it refracts. Let's do another demonstration to see if we can understand it better. Now here I have a large vase filled with water. The upper part is just air and the lower part is water. I have my pencil again, but now we're going to pretend that this pencil is light and watch and see how it travels through the air as opposed to the water. As the pencil or light is going through the air, it's going straight down. As soon as it touches the water, it bends and it goes in a different direction. This is called refraction. Let's have a little bit more fun and learn about light. Well, here I have another beaker filled with water, and I have some glass stirring rods. I'm going to put them in water and start with one. And let's take a closer look and see what you observe. So this makes sense. This glass rod is inserted in the water, and we can see both the top and the bottom. And similar to the pencil, it does look like it's broken in half. It doesn't look like it's a straight line. And we know that's true because as the light travels through the air, it's going at a different speed as it is through the water. Index of refraction is different, making the light bend, giving us the appearance that the rod is broken. Let's try the same thing, but now I have some vegetable oil inside of my beaker, and I have the same glass rod. Take a really close look as I put it in there. Oh, what's happening now? It looks like the glass rod completely disappeared. You can't even see it down there anymore. But we know it's here. Not magic, not a trick. The glass rod is completely intact. But let's watch it one more time. As I put it in, it looks like it's disappearing. Put one more in, another glass rod. And whoa, look at that. You cannot see the bottom of it. Let's make things a little bit more interesting. Look at this. Now I have water and oil. Now I'm going to take my glass rod again, and let's see what happens. As I put it in the oil, well, it disappears. But then, whoa, look at that. Ha! You can see the glass rod on top. Looks like it's disappeared here, but it reappears at the bottom. What is happening here? Let's put another rod in there. And another. You cannot see anything in the oil layer, but it's definitely in the air and the water layer. So let's talk about what's happening here. Let's do the oil first. As we put the glass rod in, we see that it disappears. The reason it disappears is because both the glass rod and the oil inside have the same refractive index. They are both bending light, but at the same index, which causes it to disappear. Now in this case, we see the rod through the air, disappears through the oil, reappears again through the water. Refractive index of the oil is the same, not the water. That's why it disappears and reappears. You can try something similar if you have Pyrex glassware at home. It has to be Pyrex. And the secret ingredient I have here, it's not just any oil, it has to be Wesson oil. You can place smaller Pyrex inside of a larger Pyrex and see if you can get it to disappear. If you are doing this, make sure you have permission from an adult as well as supervision from an adult. Now let's go back and see if we understand these jelly marbles that we had hidden inside of the water. In your enrichment bag, you each have a yellow manila envelope with quite a few jelly marbles. The jelly marbles look like this. They are dry, have not yet turned into this. What you have to do is take these. You can take 3 or 4 at a time, place them in a cup of water, and you'll actually watch them grow and expand. This is a polymer, and it grows and expands as you put it in water. The longer it's in the water, the bigger it's going to get. And if you want them to shrink up again, take them out of water, put them on a plate or a bowl, and watch them shrink up back into this. Now let's talk about what's happening here. Why is it that we can't see the jelly marbles? You can see them in air, but not in the water. That's right. They have the same refractive index. They are refracting, they are bending exactly the same. That's why they disappear. We can't see it. Go ahead, try these experiments, and have lots of fun.